As humans, if we were to wake up with some symptoms of disease, perhaps a sore throat, aching joints, or stomach cramps, we can easily go to a doctor and they can diagnose and treat us relatively quickly. But what if you were a dog? If your only means of communication is a bark, how can you be expected to list your symptoms, give your medical history, and still be home in time for dinner? If you cannot communicate with your doctor, their only plan can be to perform a series of tests in the hope that at least one will be helpful. But what if there was another way? What if we could learn enough about the structure of dogs to recognize if they have a disease from a simple photograph? Consider the Cavalier King Charles Spaniel. This dog is known to suffer with breeding-related diseases with high prevalence. One example is Chiari-like malformation, CM. CM causes deformities in the brain, head, and spine and is only diagnosed after an extensive clinical exam, including MRI and CT scans. We can take advantage of these imaging scans acquired by vets and build them into a database. We can use breakthroughs from artificial intelligence to analyze these scans, searching for signs of disease and to discover new signs. My project was supplied with the MRI and CT scans from hundreds of Cavaliers, many of which having CM, the others being healthy. We fed these scans into computers where we developed a specialized encoding process, allowing us to store dogs in terms of a unique numbering, much like a barcode describing each dog's head. AI algorithms then probe these numberings, searching for anything that is exaggerated in dogs with disease. These findings are then extrapolated back onto the original MRI and CT scans, which lets us see which regions of the brain, head, or spine are deformed by disease and what these deformations look like. Our results have found several physical changes linked to CM unknown to the veterinary communities beforehand. These include excess pressure on arteries within the head, as well as a shortened muzzle and an overall smaller skull. These findings will help to bolster the clinical understanding of CM and help to build a triage protocol for in-practice screening for the disease. The future of this research extends beyond the Cavalier and will have strong implications for both veterinary and human medicine. By applying these AI techniques to other types of imaging data, we will unearth how a disease manifests on the inside from the outside.